Okay, welcome to another edition of Cell Phone Physics Labs. What we're going to do today is to look at the acceleration or or determine the acceleration of this green cart as it rolls down this ramp. This ramp's at a bit of an angle. You can't see it here given the angle of the camera, but it is at something of an angle. We don't particularly care about the angle. We're just going to determine the acceleration. What we're going to measure is the position of the cart and the time of the cart. So those are what we're measuring, position and time. Given the position and time, we'll be able to calculate the velocities, and once we have the velocities of the cart as it moves down this ramp, remember it'll be changing. Once we have the velocities as a function of time as the cart moves down the ramp, we will be able to determine the acceleration of the cart. So again, we're measuring time and position. From that, we can determine the velocities, and from the velocities, we'll be able to determine the acceleration of the cart, which, assuming that the forces are constant, should give you a constant acceleration. I said a moment ago that all the forces should be constant. Every once in a while when I do this, the force actually changes. Perhaps there might be a little bit of debris in on the ramp here. Maybe there's a piece of sand or a piece of dirt in there. As the cart rolls down, hits that piece of dirt and suddenly slows down, gets past the dirt and accelerates and goes on its merry way. That's actually really interesting. You really won't be able to see it as it rolls down. You won't be able to see it in the data as I will show you in a minute, but it will show up and be really interesting on the graphs that you end up making. Okay, now how this works, I have a ramp here. It's a bit of an angle. I have physics books here, Since you probably don't have one at home, we have to put them to use somehow. The physics books down here will keep the cart from rolling onto the floor. The physics books here are to give it to give an elevation to the ramp. Right here you can barely see it, but here is a electromagnet which pulls down on this piece of metal. What runs underneath that metal is this paper tape. And right here, if you zoom in, perhaps you'd see it, right here is a piece of carbon paper, okay? When I turn the electricity on, it energizes the electromagnet. The electromagnet turns off and on at the frequency of the electricity in the classroom, which is 60 hertz. So every second, the electricity flips directions. 60 times a second it flips directions. And every time that happens, it pulls this down, and the carbon paper will leave a mark on the paper tape. Okay, so as it goes down, the paper tape follows the ramp, and you get information, both spatial information, position information, and temporal information, timing. So on a single piece of that paper tape, we will have both position and time information that we will then measure using a meter stick. And like I said, the time between each dot, right, one dot followed by the next dot, will be 1/60th of a second. So we have all the information that we need. I will turn this on. When I remove this, it will start to roll down. So what I'll do is put it back to the original position, turn the electromagnet on, take this stopper away, and it will roll down. Keep in mind when you're analyzing this, when you plot it, the initial velocity is not going to be zero. When I first turn it on, there's going to be a big smudge because it's not moving. This thing's going up and down, just leaving a bigger and bigger dot. As it starts to move, as it goes farther and farther, as it moves faster and faster, the dots between each adjacent dot is going to get farther and farther away. In the beginning, those dots are going to be indistinguishable. So what we'll look for is the dots to be far enough apart so we can distinguish them, and then from there we will start our data. So when you plot it, the initial velocity is not going to be zero. Keep that in mind. So let's get this started. I'll turn this on, take this away, let it roll, and bingo. Okay? Not quite sure you'll be able to see this, but if I hold this up, maybe you will, maybe you won't. There are a series of dots there that we will then analyze.